example like that?
But of course, you seek in the question 2, we have another example, Miss. In the question 2, we have another exponential. But you understand the general situation or no? So you need to recognize 50-50. Is exponential growth or exponential decay? How do you know that? According to the base. Si the base is 1/2, que es less than 1, es obvio que the exponential is decay. That is a reason que they share this. Now you plot the famous 3 point. 3 point is 0,1 universal and 1 comma the base, que the base is 1/2 in that case, no? And negative 1 comma reciprocal of the base, que the reciprocal of the 1/2 is 2. Bam, 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 3 point. You are doing approximately your graphic. And also don't forget to draw the horizontals. Let's do it one more. Of course, let's do it one more. Let's do the second example. Okay. I don't know exactly. It is the first question in the test. Okay, I don't know what is the base. Or I don't remember what is the base. Suppose now we are doing the graph of the y equal 4 to the x. Ooh, in this case, it's obvious that the base is 4. And when the base is 4, que es a number greater than 1, we are doing the graph of the exponential growth. So my exponential, when I finish, look like that growth. Okay, from left to right is increasing function. We plot the famous point 0,1 universal for any exponential. 1 comma the base is 4, 1 comma 4, I plot that 1 comma 4, and negative 1, and the reciprocal for is 1/4. Okay, negative 1, 1/4 is half of the half. I suppose que is here approximately negative 1 comma 1 over 4. Now ready to do the graph of the exponential, que is you connected the point approximately like that, using my best. And this is asymptotically approaching to the x-axis. And don't forget, please, the horizontal axis. Any question? Now super clear.
Yes, Professor.
Yes.
That's it. That's it. Identification, what kind of exponential, decay or growth, that depending on the base. And the 3 typical points. You plot more. Another possibility is, guys, do using Desmos. You put it in Desmos, but don't forget, I don't want to see playing the graph. No, you need the points, you need the asymptote. Okay, this is important piece of information in the question. No problema.
No.
Okay, let's move on to this next question. Que look like horrible because it's a typical word problem. Okay, the word problem say number 3. They say no, let me see those type of the graph with only 3 points. Yeah. 3 points is the minimum, you know. So you plot more points, it's much better, right? But the minimum because in the line we need 2 points. Bam, bam, line. But on the curve, boom, 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 you need at least 3 points. So you need more, 4, 5, okay, 6, 7, more accuracy. Our graph is okay. That's clear? Guys, this is a review. Any question, don't hesitate. This is a moment
Yes,
to...
clear.
Michael, please. Okay, Michael. Number 3. Number 3 is the growth of population fit the exponential function. Okay. Number 3 say that the function is p of t, population is equal 346 exponential using base e and the 0.05 t. It's a mathematical law. where T is a number of years, since 1978, estimated population in 211. Okay, okay. Let me try to understand. To understand, I highly recommend do the sketch, because one picture is much better than 1,000 word, blah, 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 blah. This is the time in years. This is population. Population of the, I don't know, population. And the formula of the exponential growth, you know that this is P null e to the KT. You compare, es obvio que P null es 340, 346, and K is 0.05. Que, by the way, is positive, that indicates us that this is exponential growth, and at t equals 0, in our hypothetical problem is 1978, at the beginning, the population is 346, and this is the condition 0, no? I guess so. And the exponential look like that, because it's exponential growth. I don't care the negative part. I don't care the past. I care only the present and the future. Okay, now I want to investigate what's going on at 2011. Entonces now I need to investigate how many population, no? How many something is here. This is mine or not. Do you understand very well the problem? The sketch is clear to understand this or not?
Yes.
Yeah, well, generally the student just say yes. There another student
Yes,
is
Professor.
okay, cool. Now I try to find the direction in years between 2011 and 1978. Okay, by the way, when you're subtracting, give me 33 years. Do you follow me? So the thing I did was subtracting 2011, 1978 is subtraction, 33 years. So T is 33 years. And just plug it in the formula, no? In the formula say population in 33 is equal to 346. Multiplication, of course, e to the minus not positive 0.05 times 33. Entonces, when is population, you truncate or round off to the near whole number, no decimal. Because it's supposed to be Z or Biro, it's a physical thing. So everyone working in the calculator, you put 346 times exponential function. I suppose you know very well how you find in your own calculator, and you put inside the argument 0.05 times 33 and close the parenthesis to indicate that this is exponent. Come on, everyone working, I need to know the answer. Es 1,801. Entonces es, you know, es 1,802 maybe, no? Because the next digit is 6, you round off to the near whole number, so you can estimate like that. In this case, overestimate. This is not critical, guys. See, you in the test write using decimal, it's okay, I understand. Si you round underestimate, o sea, you suppose que es 1,801, it's okay also. You are close. Okay? It's not critical. The critical is the formula determine the interval in between 2011 and 1978, que 33 years, and that's it. Cool?
Yes.
Okay.
Yes.
May I raise the board?
Yes.
Yes,
Mm,
Professor.
mhm. I know very well the voice of Elsa. But what is the other girl is speaking?
Sophia,
Oh, Sophia, the famous Sophia.
I'm
Sophia,
sorry. It's because the winter, so my voice is starting to change because my allergies.
wow, like me. Uh, Sophia checking, Sophia Adolfi, no?
Yes.
Oh, Sophia, no. You have two Sophia in this class. Checking the canvas. Any problem you see in the grade, you communicate with me, right? But remember what is the due date to fix everything. Guys,
Yes.
after December 14, I cannot do nothing for you. Because I need to turn in the grade. Okay, entonces to fix it it's very, 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 very complicated. Very complicated. Not impossible, but very complicated. You try to avoid that. Try to do your best before this day. December 14 included final exam. Okay? Any discrepancy? It's a recommendation for everyone, not only Sophia. Checking in Canvas, si you see any discrepancy, immediately communication. Si you are true, si es correct, I fix it. Si it's wrong, no. I suppose que it's a joke. It's your joke. Okay, number 4 is about money. Entonces we have two situations. Suppose that $15,000 is a present value, I suppose, no? It's the money you have right now. Which does yield the greater return? Okay, because you have two possibilities, no? Possibility A and possibility B. Possibility A is you deposit that money in one account que guarantee me continuous compound, continuously, like adjective or continuous, like adverb adjectives, continuous, and another que es no continuous, semi-annually, que obviously semi-annually is equivalent to say and equal to, because my money increasing, supposedly this is the time, this is my money, suppose that this is 1 year, suppose 2 times in 1 year, 6 months, my money, and the other 6 months, my money. If for the next year, a similar situation. Do you understand the idea? Compounding and equal to. And the
Yes.
interest, and the interest rate, for the continuous is 0.095. It's present decimal, no 1, 2. You move the decimal point 2 places to the left because you are divided by 100. And the interest rate in this is 0.092. And the common in both situations is 10 years. 10 years. And that's it. No more information. You need to find the future value and compare. See, the future value in this case is completely opposite. And the one problem that we are doing before, in which you predict the present value in order to select the cheaper option. No, in this case, no. In this case, return. Entonces, what is the best option? Obviously, the option can offer a greater return. Okay? Now you compute the future value in both situations. You split the problem in two parts. Bam, 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 bam. Now using the formulas. What is the formula for the future value in the continuous? Is P exponential RT. And what is the formula for the discrete? Any discrete future value is equal to present value, parenthesis, 1 plus R over M raised to the NT. Okay? Let's do it, but one by one. The computation you should do is 15, the present value, multiplication, don't forget multiplication, E to the 0.095 multiplication by 10. Come on, let's do it. I type in my calculator, right, 15,000. Don't forget 30. Multiplication. Oh, okay. Mike say, but Mike, let me finish. Exponential what? Exponential 0.095 times 10. Boom, exactly Mike said. Mike said the answer is 38785.64. Remember, you trunk it in 2 decimal place because it's the money, right? 38,785 $785.64. This is the return using the possibility A. The possibility B is future value is equal exactly the same present value 1 plus R, que es 0.092. I don't think so, Michael. Let me try. Es n is 2, and the exponent is the multiplication, n antique is 20, no? It's 20. It's 20 because semi-annually in 10 years we have 20 period, okay, in the total account. Entonces, you put 15, 30, don't forget 30, because it's 15,000. Okay. Okay, now let me finish. Multiplication, open parenthesis. Inside the parenthesis, I copy 1 plus 0.092 divided by 2. Close the parenthesis, I put the power, get the power, that symbol, 20. So at the display of the calculator, I type in something like that. Look. 15,000, 30, multiplication, open parenthesis, 1 plus 0.092 divided by 2, close the parenthesis, power 20. And the calculator, the majority of the calculator, the power symbol look like a roof of the house, like that. Power. Okay, there you go. And the answer, I get the answer. Uy, I get the answer. Come on, who help me? The student gets typing in the chat, make a mistake. What is the future value in that case? Is, yes, Gloria. 36, exactly, Gloria. $36,874 and 40 cents, I guess so, 40 cents. Are you agree or disagree with this answer? Yeah, Daniel. Okay, entonces, this is the moment, I compute everything. This is the moment to make a selection. What is the best option? What is the possibility to produce yield? Is the verb que es used in the problem. You select the option A, possibility A is the best. I select this. I select this. Any question? What part you don't understand? It's a review. Guys, Anika, you need to do, this is a moment to practice a little bit. Well, no, now, necessary, because in the homework you should do, okay, by the way, I see the section, some students, I suppose 50% of the class doing perfectly, doing the homework. This is the logical path. Do the homework, pretest is optional, Pero pretest is the thing I create similar to the test. This is like a trial of the test. So you take directly the test, well, okay, you have no extra credit, number one. And number two, you see the movie without trail. Okay? You risky that. And some students are doing well without homework. Okay, cool. Cool. He's a smart guy or go to the tutoring, something help, or no. I don't care. This is not my problem. Okay, now any question number 4 problem? No?
No, Professor.
I can erase.
No, Professor.
Okay. Now we come back again to graphic. We come back again to graphic. Graphic of logarithm now. Uy, pero graphic of the logarithm, remember, logarithm is inverse function of the exponential. Entonces the graph is different, no? The graph is different. I do by hand because in the test, I want to see, so the test provide a rectangular coordinate system. Entonces, the logical say, some students doing separate on the piece of paper, no? Hello. Okay, so I provide you one rectangular coordinate system to do the graph. Entonces, I suppose that you are doing the graph on this. Okay, another possibility, you are doing decimal. Okay, I understand. And you copy the pictures, a screenshot, and you put it exactly in the place of the test here. I understand? No attach, so you know, on it. Okay. The first is the function y equal logarithmic base 2 of x. Oh, this is super easy. And the second is logarithm base 1/2. Wow, this is a little bit more complicated. But no big deal. So now, remember, logarithmic, we have the universal point, que es the point 1,0. Bang, I plot that, 1,0. Where I come from this? Well, because I know the logarithm of 1 is 0, no? You know the logarithm of any base of 1 is 0. It's universal. And where I come from this? Well, it's the property number 1 that we need to remember, but it's easy to remember because it's the same point of the exponential in which you interchange x and y. So the universal point in the exponential was 0,1. Now, and the logarithm would be 1,0. Cool? Now, you put arbitrary. Some people, wow, some student crazy, start doing arbitrary point. You put in the calculator. Well, you can do that, of course, but it's no logical, in my opinion. No? You plot 3 points. What point? The point, for example, logarithm base 2 of 2. Que es the coincidence, the base an argument que es 1. Entonces the point is 2,1. 2,1. But let me erase this. Let me copy that point here. 1,0. The second point is 2,1 here. Do you see? 2,1. Because you can select 3, but 3 is decimal, horrible, irrational. So now my recommendation is using the more clear point. So logarithm base 2 again, we are doing the same graph of the 1/2, que es the reciprocal, es -1. And the point is 1/2, -1, que I suppose, using my imagination and common sense, que es 1/2 in x and -1 in y. Boom! I have this point, 1/2, comma -1. Ready, 3 points, enough. Maybe you plot another, logarithm of 4 base 2 is 2. It's another point, but no, not necessary, not necessary. So you are doing the graph like that, connecting by the curve. I need to know also that that curve of the n logarithm is asymptotically, but in this case, vertical asymptote, not horizontal, to the y-axis. We have here vertical asymptote at x equals 0. And it's common. See, we have no transformation in this example. I don't know why in the review and the test don't put transformation. So the asymptote stays the same. It's basically function, the basic function. Now, you follow me? You follow me?
Yes.
Yes.
Now, let's move on to the 1/2. Oh, well, 1/2, I need to know, the intuition say, this is the logarithmic growth, like that. But this is logarithmic decay, so it's like that. But suppose I don't know, I don't care. You are doing similar situation. You apply 3 points. Logarithm 1/2 of 1/2. And the argument, sorry, I copied wrong. Not wrong, weird. 1/2 is 1. By the same situation, they are perfect coincidence in between the base and the argument is 1. However, when you have logarithm 1/2 and the reciprocal, que es 2, where come from 2 is the reciprocal 1/2, flip it, is -1. Wow. Therefore, be ready to plot that point. 1/2 positive 1 is here. Let me make it zoom to see more clear. 1/2 here and 1. Plot that point.